So Assalamualaikum, and a very good day. So today I'm going to show you guys how to make a solid project on Solidworks app that you can get in Microsoft, not Microsoft, in our laptop, PC or sorts. So my name is Muhammad Zabidul Aziz, and my Solidworks project is called Pneumatic Motor, or what we usually call is pump motor. So let's get started.
So this is the one of my project, and in isometric form atau isometric view. So the view from I go to the sketch. So the sketch the dimension for this one is 50 mm, and for the horizontal one is 82. So when I shoot it, it become a solid 3D object like so. So for the hole, I use a nail hole. We tap hole 2. There's 4 holes, and 1, 2, 3, 4. The depth of each hole is 8 mm. Each hole is 8 mm, as you can see. And for the edges, I use chamfer with 1.5 mm and 44 degree. So that is for one, and I take it back to the isometric view, and then for the drawing for this part, this is the drawing for this part with the dimension. As you can see, the diagonal is 50 and horizontal is 82. I use M4 tap hole, which is 3.3 diameter. Now I forgot to mention the height of the both axle is 16 mm. And so that's it for part 2. This is the part 2 of my project in the isometric view. It is a metal object, and for the sketch, I use a straight line from fronting. In this sketch, you can see this is the dimension. This is the dimension. The thickness of this metal object is 2 mm. The height is 18. So this shows the one shown is 16. And for the top width is 28, but from the inside is 24. And the total length of this object is 48. For the smooth edges, I use fillet, which is 2 mm, and for the top one I use 3 mm. For this, I use the extrude cut. This one, which is the horizontal one is 4, and the diagonal one is 4, and the horizontal is 14 mm. Okay. this, because this will be the place where the crank will rotate here, and this is the block. So next one is the emitter hole. The emitter hole is the emitter hole is for the emitter, and all of them is the same, and this is the gap, the length between each of them, for like this and from this hole, the edges it is 5 mm, and between this and this it is 25 mm, and this from this center to this edges it is 5 mm. This is the same like this one, and between these two across each other is 38 mm, and that is for these two holes. For these two holes, you can see same diameter with the dimension of gap, which is from here, from this edge to the center of this hole it is 8, and from this hole to this, from the center also to the center of hole is also 8, which makes it 16 from these edges. So that's for part 2, and for this drawing, as you can see the dimension, the height which is 18 like I said, and the width is 48. So for part 2, we go to part 3. Part 3 is the main compartment for my project, which is the block. So this block consists of many things, which is kind of the most complicated one for this project. As you can see, there's a lot of hole, tape hole, and a lot of hole. So we go through it one by one. So the first thing that I'll do is, let's see the dimension for this. So as you can see, the height for this compartment is 62 mm, and the width is kind of like 40 mm. The width from here to here, from here to here, which is 40 mm, and the width for this to this point to this point is 90, and this point to this point is 12, and this point to this point is 40. The height from bottom to the center to this center is 30, and this to this point is 38. So that is the smart dimension, which is the sketch that I've done. Now let's go to the top plane and see the sketch for my hole. So this hole has from the center, from the edge to the center of the hole is 10 mm in say gap. So this hole has a 14 mm diameter, and then there's another hole here which has gap from its center to the edges of this side, which is 24 mm, and the diameter of the circle is 4 mm. For 4 mm this circle. Then I draw a line, then I mirror it here, and then I use the hole wizard to make the tab hole. This step hole has a 3 gap between its center to this edges and this edges. It is the same, and between this hole to this hole it is 14 mm. And for the right hole, for this right two hole, from their center to this edges, which is 24 mm. And this hole has a 2.5 diameter. Then I use the hole wizard to make it a tap hole. And their depth is all 6 mm for their depth, all the same. Then let's go to the SO3, which is this hole. This hole from this it has a 5 mm diameter, which gap from the center to the bottom 20 mm, and from the center to the right edges, which is 8 mm. So for this hole I just use cut extrude. Then let's go to the next hole, which is this hole. This hole has a so it has a 19 diameter, and I use the cut extrude. Oh, I'm sorry, this is the box extrude for when I'm doing this, but there's been some mistake and I have to redo it again. So this this then this gap between these two holes, I draw a line to make this gap, and then I use cut extrude, and then I click here to get the depth, and the depth is kind of like 2 mm, 1 mm, I think 1 mm. Then use and then for this way, there's 8 mm of diameter, and from the center to the bottom edge it has the height from this edge to the center is 10 mm. Then there's a chamfer on this side of the hole. This chamfer, the chamfer I use is 1 mm times 45 degree. Then there's this long hole, this hole, which I use the hole wizard again. This hole has 48 mm of length, 4 mm of diameter, and that's it. Then there's these two holes to allow air as we know that this is for the piston, and this is the intake and the suction and outlet, something like that. So for this hole has 3.2 mm of diameter, and their gap from each other is 6, and the gap from the center line is 3. This is the center line, as you can see. That's for the tap hole. Tap hole from this, from at the bottom. Another tap hole. This tap hole has a 2.3 mm diameter, and their gap from each other centers is 8 mm, and this one centers from the right edges is also 8 mm, and they are being perpendicular to each other, and they go to this surface of hole. So the last one is this hole, which connect this hole to this hole. As you can see, this hole. This hole has a 2.5 mm of diameter, and it goes right to surface onto this hole. So that's it. That's it for part 3. Then go to the drawing of part 3. So this is the drawing of part 3 with the dimension. You can see this tap hole, this is the tap hole, this tap hole, and this is a hole that goes right to the surface, and this hole that is cut through. So that's it. So let's go to part 4. For part 4, it's a simple compartment, which is the piston head. It will go on top of the block. So for this compartment, the dimension of it is 20 times 28 mm, and their height, which is the thickness, is 3 mm. For the hole, I use tape hole from the hole lizard. As you can see, this is the dimension. Their gap from edges to edges is 3 mm and 3 mm, and their gap from this hole to this hole is 40 mm, and their gap horizontally is 21, but on the right side the gap is 4 times 3 mm on the right side. Same goes as down here. And this hole doesn't have any depth, as we know, as you see, it goes through all, and that's it. So let's go to the drawing. So this is the drawing for this compartment. As you can see, the height, the thickness, the height is 3 mm, and the hole is 2.5 diameter declared, and the width of this object is 28. So that's the drawing for this part. So let's go to part 5. So this is the part 5. Part 5 is the flywheel for this pneumatic motor project. As you can see, so let's go to the sketch of this flywheel. So there's 5 holes, and 1 hole in the middle, and 4 holes along the middle hole. So for the outside hole, it has 10 mm of diameter. All of it is the same, but for the middle hole, it is 8 mm in diameter. And also the gap, there's a hole, there's a circle that I've made here. It is which is used to make guidance or to make this hole perpendicular and straight. And so the diameter of this big circle, this flywheel, is 50 mm. As you can see, so that's it. Then I use box extrude, and the thickness of this flywheel is 9 mm. Then to make the hole, I use cut extrude. As you can see, cut extrude. The big circle, so I use the circle, this circle, which is 36 mm, which cover all the hole in here, in it, and then I use cut extrude, and the thickness for that is 4 mm. We don't want it to go all the way, it just halfway. And then there is this part, the circle. Now this I have to sketch, which is 12, a little bit more from the other circle, which is 10. This is 12 mm in diameter, and I use the extrude 1 mm to make it appear a little bit out of the surface. 2 mm, not 1. So that's it for this flywheel part. Then we go to the drawing of this part 5. So this is drawing. You can see this 4 hole. This is the hole with the 9 mm diameter, then 12 mm diameter. This is 10, and the big one, this is flywheel. This is the boss extrude that kind of show out of the surface. So that's it for part 5 drawing. Then let's go to part 6. Part 6 is the crankshaft for the pneumatic motor. So for this part, I made a circle from the front plane, and then I use boss extrude to make it solidify like this. Yeah. So let's see the sketch. So the circle that I draw is 8 mm diameter. That's the thickness or the big how big it is. Then for number 2 is this one. This is the like something that blow out of the surface of this circle, which I use the extrude and width 4 mm of diameter, and then at the tip of it I use chamfer, which is 0.5 times 45 degree. And then there's a diameter hole, which is the hole right here, the hole which I use sketch. It has a 3.2 of diameter, and 14 mm of length. This one I use the hole. And then for this bottom up top hole that I use cut extrude. the bottom and top. So this is the sketch. This edges from this edges gap is 0.5 and the width of this hole is 4, and the thickness, the height of this hole is 1.5, same goes as the bottom one, but and so gap 1.5, but the width is 12, and this is 4 mm and this is 12 mm. Then I just extrude to make this hole, and then I use the hole, wizard hole, to make a diameter hole. I use the center line to make it as center as possible when sketching, and then I use the Z to make the hole. So the hole has 2 mm of diameter and 0.9 of depth. So that's it for the part 6. So let's go to the drawing. This is the drawing with the dimension. Like I said, the dimension, as my dimension is kind of the same like I just said before. So let's go to part 7. So part 7 is the crank, the rotating part of the motor, one of the rotating part besides crankshaft and flywheel. So crankshaft, I build it using let's go to the sketch. So this is the sketch for the crank. As you can see, the sketch is basically has a lot of circle. This is a circle, so like half circle, and like this circle it has 4 mm of diameter, and the bottom one has 8 mm of diameter. As you can see, it has bigger diameter, and there's this one, the circle that will pop out of the surface, which has an 11 mm, but the gap between this and this is 3 mm. This one. So the gap from this circle centers and this circle centers is 8 mm, and the diameter from this to this is 15 mm, which makes this like tangent, and then this straight line is perpendicular to each other, like mirrored to each other. This is the line. So then I use cut extrude to make this hole. I use boss extrude from the sketch and select the surface that I want to extrude, boss extrude, and this hole I leave it be because I want it to be a hole. So then the boss extrude is from back this 11 mm circle with 0.25 thickness. So that's it for part 7. Let's go to the drawing for this part. So this is the drawing for this part with the animations, basically the same. Let's go to part 8. So the part 8 is the connecting rod. So the connecting rod is the main compartment that connect the piston and the crank, and also the crankshaft. So the connecting rod, I make it from front plane, from top plane, and then I sketch it, and this is the dimension. For the circle here, it has 4 mm of diameter, and the big one is 8 mm diameter, and the gap, and there's a small circle at the right which has 3 mm of diameter for the small circle. The big circle has 6 mm of diameter. So the gap between these two circle centers is 35 mm. And then I draw a line of 6 mm, same goes to this 6 mm, which way is horizontal 90 degree 180. And then I draw a line here and here, and then I make a tangent right here, which has an 8 mm radius. Same goes right here, here and here. But the gap between the dimension for this, from this to this, must be 4, which is from the center must be 2. Must be 2 mm. So, and then I boss extrude it. I select all the surface that I want to extrude. I set the hole because I want to make it a hole. And then you're done. And then you get a branching rod, just like that. So let's go to the drawing for this part. So this is the connecting rod drawing. This is the top plane. This is the front plane, and this is the right plane. Let's go to part 9. This is the piston. This is the piston. Let's go to the sketching of this piston. So this is the piston. I use the revolve method. So I use a center line here. Then I sketch from here to here to here to here to the bottom, and then here and then here. So the dimension for this line is 6.5, and this from tip to this is 7. The thickness from top to this bottom line is 1 mm, and then it goes right here, also 1 mm. And then from this top to this bottom, it is 14 mm. Like this, 15 is from here, so I just minus 1 to get this to this. And then for this dimension is 0.5, and then from this to this, it has a radius of 4.75. Radius from this to this, and 30 degree. Then this to this, there's a degree of 59 degree from this to this, from this interline to this line. And then I use resolve, and then you will resolve around, like this, and make this piston. And then for the hole, I use cut extrude, which is I sketch at the surface from front plane, and the hole diameter is 3 mm, and the gap from the center of this hole to the bottom is 7 mm. So that's it. Let's go to the drawing. The drawing for this piston is like this, and this is the top plane, front plane, and right plane. So like I said, there's this circle that I use cut extrude, and then the resolve piston. So that's it. And then let's go to part 10. So part 10 is like a pin that is used to lock the crank and the crankshaft, like a pin. So for this is a simple sketch which I use for the circle. It has a 4 mm of diameter and 13 mm of length. Then for this one is there's like a whole gap right here. I sketch it right here, and then I use cut extrude, but I cut it right here and cut it outside, not inside, so it will be like this. And the diameter is 3.8, so there will be a 0.2 gap from this to this. Then for the tip, I use chamfer 0.5 times 45 degree. So that's it for part 10. Let's go to the drawing of this part 10. This is the top plane, this is the front plane, and this is the right plane. Let's go to part 11. Part 11 is just the pin that are connecting the piston and the connecting rod. So it is a most simple part that I have made for this project. There's a 3mm diameter with a 13.5 in length, as you can see like the sketch. And then for this tip and this, I use chamfer. With 0.2 times 45 degree to get this chamfer. The bottom and the top one is the same. So that's it for part 11. Let's go to my last part, which is part 12. But first, let's go to this part 11 though. So this is the drawing for part 11. This is the top plane, this is the front plane, and this is the right plane. They are all equipped with their smart dimension. So let's go to the last part, which is part 12. This is like a bush used to lock the crankshaft with the pin. So this is the most simple compartment that I've made. So let's go to sketch. So the inner circle is 3.8 millimeter and the outer circle is 6 mm in diameter, and the thickness of this bush is 1 mm, as you can see. And then I use project stroke to make it like this. So that's it. Let's go to this drawing. So this is the top plane, this is the front plane, and this is the right plane with their dimension. So that's it for my parts. Next we will go to the assembly. So let's make the assembly from all the parts for this project. So let's file and make assembly from part. Then when we are here, click the part 1, insert it, insert component for part 1, make it asymmetric, tambah a little, and then insert another component which is part 2, and place it right here, and then move this component. Let me and just to make this blank space go up front, and then you go to make, select this hole and this hole, then you go to right and then select. So as you can see, there's already been fixed, so let's select the other hole, select right, and then this hole, yes, also this hole and this hole, then click yes, and then make. As you can see, this part is already been fixed to each of their holes, and then go to the make again, then we select this surface, go over there, go to make, select this surface and this surface, then make coincidence and click yes. So this part has been fixed. As you can see, it cannot move. So let's make this, let's go to view, then you go to assembly, insert another component which is part 3, then you go to the move component, like this one, move this component, then you click on make, select this hole, this hole, right, and then if you little bit up, then you select this hole and this hole to make it fits, make it concentrate, and then you click yes, yes. Then you go to the make again, you click on this face, and then you click on this block surface to make it attach, and then you click on yes. Then let's make this as an isometric view. So for the next part, let's insert another component, which is the piston, which is the part 9, part 7 I think. No, it is, it's part 9. Insert the piston, and then insert the connecting rod. You can also insert this. And then insert the crank. This is the crankshaft, this is the crank. And then insert the component, and the connecting rod, like so. And then don't forget to insert the pin for this rod, connecting rod to be connected to this piston. Pin should be compartment number 10. So what I have to do right here is move component, this component first. Then you go to make, you make this, then you can see it can be like this. Then you make this surface of this pin with the hole in the piston. So it should be like this. So let's move it in. Then you go to make, and to make this pin fits, you need to make it with this surface, so then it will be fixed. So to make the connecting rod become fixed, all you have to do is just click on the rod and the pin. Then you can press Ctrl right plane, press Ctrl top plane, and press Ctrl front plane. And then you click on the mouse and then click make. Then when you click make, this command should be fixed. And let's try it again. yes and yes again. For the next part, let's click make, click on this crankshaft space and click on this hole. Sorry, so let's do it again. Click on this and then click on this. Then you can see it can be moved like that. So to make it fix, we are going to click on this crankshaft surface and this surface to make it fix. So you can see it can rotate but cannot move in and out. Next, we click on make this surface of the piston and this surface of hole. So this piston can now move like this. So this crankshaft, we will fix that. So let's just move along and add another component, which is the flywheel. So the flywheel, and this is the flywheel. We're going to make it with crankshaft. So click on this hole and click on this crankshaft surface. So it is now made, but it can move like this. So what you have to do is just click on this surface and click on this surface. So then it will be fixed. This is beautiful. So we're going to insert another component, which is this crankshaft are going to be here. So there's going to be the pin, which is the purple pin, which is part 9, no, not part 9, it's part 8. So we can the part 10. So what I have to do is so there have been some mistake. So I'm going to like undo it. So this one actually you have to, this is right, but you don't have to like make this surface with this surface to make it fix. Actually you have to make another thing, which is this and this surface. Yeah, like that. So the thing is you are going to make this with this. That's the right one. Then we add another component, which is the flywheel. We are going to go at the back, so we're going to make it. face with this crankshaft face. So move this back a little. We make it again. There have been some like some sort of focus, so I'm just gonna proceed with this one first. So this piston surface will make with this surface of the hole inside. So let's do it first. So this can be moved. So to fix that, we are going to make this hole there. We're going to make this hole with this hole. So as you can see, it is right now. So not yet pin. So we're going to try this again. I'm going to make this. Oh yeah, I've been wrong. It's supposed to be this hole, not this surface. This hole, right? Okay. Then make this surface with this face. And click on yes. So let's add another part, which is the pin. Pin is going to be part 11, 10. So when you add in the pin, you are going to need the bush, which is part 12. I'm going to add 2 bush. Then we're going to put the mate and make this hole and this hole. Okay. This hole also with this hole. Then we are going to make simplify a little bit so that you can see it. We are going to make this surface with this face of the pin. Then make concentrate and then make. Then move this to back a little bit. Then maybe we can go the bit right along. We are going to go to make again. We're going to make this surface with this block surface. So it's going to be fixed like that. Then these 2 push. We are going to make it through with this pin. So click on this face and click on this and then make it concentric, and then make this with this crankshaft surface, then click on yes. Then for the other bush, I'm going to do kind of the same, this with this surface, and click on yes. And the surface is going to be this surface and this, and then click on yes. And as you can see, this we can rotate now. So let's make this an isometric view first. So let's go to this, and this, it can rotate, but it will not affect this. So what you have to do is, you go right here, not this. I'm going to go with the flywheel and the crankshaft part, which is part 6. So what we have to do is click Control right plane, and same goes with the flywheel, Control right plane, and click on Mate. Click on Mate. So let's see if this is correct. So when I spin this, it should rotate the crankshaft also. Alright, so that is done. So for the next one is crankshaft and crank. So we are going to click on the crankshaft and the crank. Same thing will happen. Click on the right pane of crankshaft and click on the right pane of the crank. Right click on the mouse and click Mate. And coincident, you click yes. So let's see if this is correct. So when I spin this, it should spin all of this. Yes, like that. So that makes this an isometric view, and make this not transparent. So close this, close this. So there's another part that we are going to add, which is the cylinder head. So let's go to its component and search for it. It should be part 4. Then click on Mate and click on this hole and this hole. So it should be that, and then make it concentric Mate, and then click on the other hole and this hole, and yes, and there you go. Then you should have something like this, but you have 2 other holes, so make it fixed. Okay, so there you go. Okay, so there's been some mistake, so I'm going to undo it. So actually you have to do is make this 2 hole is supposed to be in the front, so I'm going to fix that. Yes, then make this with this hole, so that right there. So this is correct, so move it up a bit, and then continue with this 2 hole to make it fix. So you have this fixed piston head meeting with the block. So there's another mate that you have to do, which is the surface. This surface with this surface. main. Again, surface and this block surface. Then you click on make. So like that. And then you are done. So you spin it, you spin. So there's another thing that we have to do, which is the bolt and nut. So basically bolt, no nuts for this hole, this and the other two at the bottom. So I'm going to spin this like this so that I can see the hole. So let's add the bolts. So I'm going to go with the IN and bolt and screws and the hexagon one. So for this bottom hole, I'm going to go with the IN M12. So this is going to use M4 type and the length is 8. Length is 8 as the hole followed by the hole in here is 8 mm. So we're going to go with 8. So that's it. You click right and then you click on the other hole that you want to add the bolt. The bottom hole will also use the symbol, which is M4 and 8 mm of length. So that's it. And then for the top cylinder head hole, you're going to use the same IN, but it's going to use M3. Yes, M3 correct. And the length is going to be 12. So the length is going to be 12. Click on right and then you put all the bolts. Then there you have it. You are done. Let's make this and yeah. So that's it for the assembly part. So now let's go to the animation, which I'm going to show you how to make the animation for this to spin. So as we know that this part is fixed with this, and this crank part is fixed with the crankshaft, and the crankshaft is fixed with the flywheel. So what you have to do is click on motor, click on the crankshaft, and then you go to the motor edge and speed you can adjust. So for me, I'm going to go with 80 rpm, rotation per minute. Then you play right. So let's try it. So as you can see, the pneumatic motor is spinning. So for the exploded view, I'm going to add I'm going to add the motion study, which is motion study 2, and then we are going to go to do the exploded view. So the first one is we are going to play this. This is the part that will come out first. These 4 parts. Take it as high because the air part will also be dragged up, so need to be space consuming. So the next part is this, the cylinder head. Then you click done. Then next one is the flywheel. Move it back. that. So and then okay, next one is you can go with the crankshaft, put back, and done. Then you have this pin which connect the connecting rod and the crank, so you can pull it out, done. And then you will see the push, same thing will happen, you pull it out and then done. Then you will move the block. This is now not connected to anything, so the crankshaft has been pulled out, so you pull it out like that, and then you click done. And then you will see the black pin that are connecting the piston and the metal rod. Pull it out like that, and then you can now pull out the piston. Then you click done. Then you can click the connecting rod. You can go up, but I prefer to go to the left, to the front like this. Then you click done. Then there's this bush, same thing goes. And then the crank. And the next one you're going to do is the base goes down, you click done. And then the this. Sorry for the mistake. So we click on these 4 bolts and bring it up. Then click. Then these 2 bolts, going to click on that. Then we're going to bring it down. So this is the view, so it should be like this. So this is the exploded view. Then click on yes. Then you go to motion study 2. And then you go to animation wizard. Then you click explode. Next, and so for the duration I will go with 80, and the starting time is 1. Then finish. And for the we go again for the animation wizard to create the collapse view. So the duration will be the same 18, and starting time is 20. So let's play it. Then this is the collapse view. And that's it for my project. And thank you.